From the Spec Network, this is Fragmented, an Android developer podcast where we talk about building good software and becoming better Android developers. I'm DonnFelker.
And I'm KaushikGopal.
Welcome to the show.
Before we begin today's show, I want to take a quick moment and thank our sponsor, Mapbox. We're really excited to have them on as a sponsor this year. But what is Mapbox? Mapbox is the location data platform that enables developers to go off and build their app experiences. Now you may think, why would I need something like Mapbox? If you ask me, one thing, customizable map experiences. As an Android developer, especially one working on an app that has to customize the map experience, I don't want to settle for, a default same app no matter what you do option. I want to tailor the map view that I show my users so it meets their specific need when using my app. Mapbox offers complete map design control. With just a few lines of code, you can display accurate turn-by-turn driving, walking and biking navigation, real-time traffic. They basically handle location so we can just focus on building our app, and that's exactly the kind of service that we all need in our lives. Many companies and developers already integrate Mapbox today in their Android apps. I know, because we use them here at Instacart too. Just head on over to mapbox.com/Android. Sign up there, and the first 50,000 unique mobile users, it is completely free. So you can try it out to your heart's content. And after that, they have a completely reasonable pay-as-you-go model. We're thrilled to have them on as a sponsor, and we want to thank them for sponsoring today's show. In this episode of Learning Kotlin, we look at the new iterable-like data structure from Kotlin called Sequences. What is a sequence? Why do I need a sequence? When do I use a sequence? Listen on for the juicy details and also a refresher on some of the fundamentals. Alright, so Kotlin has this new data structure called Sequence. It's a data structure that's very similar to the one that we know from Java called Iterable. But before we dive into the specifics of sequences, let's actually take a look at Iterable itself from Java. What is an iterable? An iterable is simply a collection of elements that you can iterate over. So a simple data structure that has elements that you can loop over. Now, it's an interface. So typically, if your object implements the iterable interface, well, then it's an iterable, right? Simple stuff. Lists, queues, sets, basically anything that you're used to writing a for loop against are all iterables. But if you worked with Java for some time, you know that there's this other thing that sounds very similar called an iterator. Not iterable, but iterator. Excuse the dramatic pronunciation. I don't sound this weird in real life. It's just that I want to emphasize the difference between these two because they can sound very similar. So what's an iterator and how is it different from an iterable? This is actually a common Java question that stumps folks. You see, the iterable data structure doesn't actually hold the information about the current element. Or more formally, it doesn't have any information about your iteration state. So it's literally just a collection of elements. It doesn't actually have the information about your iteration state. So when I'm going over a loop, the iterable is like whatevs. I'll just take you through this thing that you can loop over. I don't have the responsibility of telling you where you are at any point of time, if you have any next element, or if you want to go to the next element. So if you were, say, looping over a list of 10 elements and you have gone through 4 of these elements, you have another 6 more to go through. The iterable collection does not hold that information. It doesn't care, right? It's all about just holding the list of elements. The information for where you are at your point of iteration is encoded in another data structure called iterator. So that's the primary difference. You need an iterator in order to iterate through the iterable, if that makes sense. The iterator is also very similar. It's just an object with a iteration state. Again, remember, it is an interface. So your object would have to implement iterator. Or the more easier practical way to think about it is You know how you wrote those iteration loops and you had methods like has next or next when looping? Well, that's the iterator doing its job because it's the iterator interface that actually exposes those APIs. All right, so to quickly recap, iterable, a group of elements that can be iterated over. Iterator, an object that holds iteration state and typically helps us go through the iterable. Now, most typically, an iterable should be able to produce iterators. So, most collection implementations or iterable data structures should have something like a get method or should expose a method that gives you an iterator object. So you don't necessarily have to create a good collection implementation, gives you that iterator object that you can use in your loops. Here's a quick exercise. Go back to your application code now and look at the different times that you've used iterable and iterator. You'd be surprised because the IDE these days is just so good at auto completion that half the time you're just going to be hitting Alt-Enter and fill it up, IDE, I don't care, just give me the thing that I need to get my code working. And you'd be surprised where each time in your mind you think you're actually using the right data structure, but if you have to recall quickly, it's kind of hard to think if it is the iterable or iterator that you have to use at that point. But hopefully, after this explanation, that should become clear. Okay, now we come to the interesting part. Kotlin introduced a new interface that's very similar to iterable, and this interface is called Sequence. A sequence is similar to the iterable in the same way that you need an iterator to iterate over it. It doesn't hold the iteration state in itself. The same thing. But there are two pretty big differences that I've come to learn between sequences and iterables. Firstly, the values in a sequence are evaluated lazily. And we'll come to what this means and the implications for this. Secondly, sequences can potentially be of an infinite size. So let's dive into what these differences actually mean. The first big difference is lazy evaluation. So sequences, I said, evaluate the values lazily as opposed to eagerly. Why did Kotlin come up with what looks like an entirely new data structure, but so similar to iterable with just this big difference? With a lot of functional style programming these days, we've begun to do a lot of chained programming or like chained operations. Well, it isn't just necessarily functional style programming. Any of the helpful API functions that you can run on collections, functions like find, any, all, filter, all that stuff. With all those helpful collection API functions, as you drop into each chain of the operation or the transformation, like the map, the flat map, as you drop into each chain, that step creates intermediate collections eagerly. So what does that mean? That means basically at every single intermediate step, the result is stored in a temporary object. So if you had a list to begin with and you're applying some of these collection functions on top of the list, then at each chain, what you're essentially doing is creating a new temporary list to store the results of the operation that you've just done. So if you had like a filter operation or you had like a map or something, the results of that is stored in this new temporary object. And if you had 4 more steps, then you have basically 4 more temporary objects created in the process, right? So maybe let's take a simple example. Say I have a list of people, each person object has a name and an age. I start off by taking a list of people. I run a filter operation first to, maybe get the list of people that are above the age of 30. Then I run a map operator to emit just the names because maybe I don't care about the person object. All I want is a list of names. So I run a map operator there. Then maybe I can run another map operation to just convert that name to initials because maybe this, the business logic, all it wants is a list of initials. It doesn't necessarily want the name, By the way, if this is a little hard to follow in audio, take a look at the show notes this time. I'm going to be dropping a lot of Kotlin code snippets and examples right in the show notes so you can, put pull up your phone, take a quick look at the show notes, and then, sometimes code just conveys information in a much more succinct way. So I'll drop this example that I'm talking about right in the show notes. So going back to the example, so at each filter and map operation, a new temporary list is created. So as you can imagine, this can land up being pretty costly if you have, say, 10 such transformation functions, 10 filters, 10 maps, whatever, that you're calling. Moreover, and more importantly, if your list to begin with had a lot of elements, like say it had 100,000 or like a million elements, then absolutely you're going to see a considerable performance hit if you create multiple temporary objects. So what can we do to mitigate this? Well, the problem here is the creation of those temporary objects, right? Which is what we call eager evaluation. If we could say, hey, just hold on for some time, look at all the elements, do the transformation per element, and then emit your result, well, in that case, we wouldn't have this problem, right? Well, that is precisely what evaluating lazily kind of means. And this is precisely why Kotlin introduced this new data structure called sequences. Sequences, unlike iterables, evaluate the elements in a lazy fashion. So they do it lazily. The advantage of this, as should be clear now, is it actually avoids having to create multiple intermediate temporary objects as you increase that chain. So if you take a look at the original example of getting people's initials from the list of people, if I took that list, transformed it into a sequence, and then ran those exact same operations, well, those numerous temporary object lists that are created along the way are avoided. So some quick notes. To transform a list to a sequence, you can do this by this very special function they've introduced called asSequence. So list.asSequence. I was kidding, it's not a special name. It's the most obvious name you can think of. And Kotlin this way has done a fantastic job with keeping clean, understandable APIs. So, okay, I have my list. I call .asSequence. I transform it into a sequence. Now I go ahead and do all my operations, filter, map, transform the list of people to initials. Now what I want to do is I want to convert it back. I want to transform it in the reverse direction. I want to convert the sequence back to a list. In order to do this in the reverse direction, we use another very special function called, wait for it, toList. I made that joke before, so I'm going to move on now. All right, to recap, when would I use a sequence? Well, typically when you want your elements to be evaluated lazily. One scenario is when you have a ginormous list and you have numerous functions that you're applying on top of that list. With each function, you're basically creating a new temporary object. That can be costly. So instead, what I want to do is I want to avoid that. I would use a sequence. With a sequence that is avoided, you'll probably see a noticeable gain depending on how big that list is and how many transformations you run on that list. All right, so I said if you want to convert it back in the reverse direction, back to a list, you use toList. Did you stop to ask why you would ever want to do this? I convert my original list to a sequence and I do all my transformations on top of the sequence. Then I said in order to change it back into a list, you use toList. But if this new sequence thing that Kotlin has introduced is so snazzy, why can't I just always use a sequence? Why do I have to worry about ever using a list now for everything? Well, the thing is, sequences are sort of built primarily for you to only iterate over the elements. Say you wanted to access an element of this sequence at a particular index. With lists, typically we would do this with list of 2, right? So I would say, give me the item at give me the third item at index 2. I would do that saying println list of 2. Go ahead and try that with sequences. If you do it, you'll get an error saying no get method providing array access. So you can't do that with a sequence. Essentially, you're out of luck if you want to pick a particular element from the sequence and say, give me the element at index 3. So for those, you would obviously have to use a list. And if you use your sequence in between for that transformation, you have to convert it back to a list. So that's one good reason to keep using lists and not sequences for everything. Because if you want access to a specific element in the list. The other reason to not go whole hog and just convert everything you have in your application from sequences to lists is that sometimes your performance gains won't actually be that great. eager operations on regular lists are actually pretty efficient sometimes in Kotlin. You don't necessarily need to have them be evaluated lazily all the time. I won't actually go into the details of this in this episode because this is something that requires an episode of its own. It's called inlining. Inlining is like this very cool concept in Kotlin, and we'll try to devote another episode just for that concept. But just keep this in mind. Basically, if you have a chain of operations on very large collections, and for emphasis on very large, then sequences are probably a good bet. Otherwise, for the most part, you can probably just keep using lists and be on your way. Now, there are also some things you have to watch out when doing lazy evaluations. Because it's a lazy evaluation, typically the order sort of matters. This is really much better explained in code, and there's this excellent Stack Overflow answer that I found that actually demonstrates this really well. So I'll drop both of those in the show notes. Have a look at the show notes. I'm not going to go through the ordeal of explaining this in audio because the code, immediately once you have a look at the code, boom, you'll just get it instantly. What I do want to do now is shift our focus on the other property. There's this thing called intermediate and terminal operations with sequences, and that relates to the second difference that I originally mentioned, which is sequences can potentially have infinite sizes. So there's this concept called intermediate operation and terminal operation on sequences. If you've ever worked with Ruby on Rails, there's this concept there called active model queries, and it actually functions in a very similar fashion. Basically, you can keep applying where clause queries on your original active model query, and those keep returning another active model query. It doesn't actually return the result of the object. So you can say on my table where name is equal to blah, 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 age is equal to blah, 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 and I could just keep chaining operations, and it keeps returning just an active model query. It doesn't actually finally run the operation in my database until you call a very specific operation, right? So this is very analogous to how sequences work. Sequences function in a very similar way. Intermediate operations are all just like queries. So if I transformed my people list to a sequence and then I just started applying filters and maps, it's not actually running anything, right? So this points to the lazy evaluation. All it's doing is just generating another sequence. You're just describing your operations. They don't actually run as you describe or define them. You haven't actually done anything on the original collection of elements just yet. So these are intermediate operations. But at some point, finally, you're going to want to say, okay, I've described what I want to do. Go ahead and do these things, right? Do those things and actually give me the results. So to give you the result, you would actually perform this operation called a terminal operation. Now, in that example that we talked about with the people and like getting the initials out for that original list of people objects, we ran filter, map, all those things, right? Those are what you would call intermediate operations on sequences. And then finally, we added that toList function, right? And this is basically why I coyly sort of try to go past that toList because I wanted to explain it in a little more depth here. That toList function is a terminal operation. It basically says, okay, I've described and defined what I want to do on my original sequence, do those things and give me the result in the form of a list. Another interesting exercise that you can do is if you have a sequence with multiple intermediate operations, but no terminal operation, go ahead and try a println on that. So try to print out the results of your sequence without a terminal operation. You actually won't see anything get printed on the console because the program's going to be like, I don't know what you want. We haven't finished evaluating the sequence, right? You just told me what you would like to do, but you've not told me to actually go and do it. So I only see intermediate operations. I need a terminal operation. Again, I'll drop code snippets in the show notes so you can actually run these things on console and see for yourself, because in the end, that's the best way to learn this stuff. Well, I hope this episode gave you an idea about this relatively new data structure and very interesting data structure called sequences in Kotlin that you could potentially land up using. And it's good to be armed with the knowledge of this concept because you might run into a situation where you would need them and then comes in really handy. Again, this is not to say go ahead, go back to your app and change every single list occurrence to a sequence. In almost all those cases, if you're not dealing with large lists and multiple complex operations, you're not actually going to see any of these benefits. So just keep this in mind and be armed with the concept. And when it actually comes useful, you'll be glad that you had this in your arsenal. All right, to summarize, iterables are a collection of elements that you can just iterate over. They don't have any info or state on where you are while iterating through items. For that, we have another data structure called iterators. Sequences are a new data structure in Kotlin. They're very similar to iterables with one huge difference in that the elements are evaluated in a lazy fashion. You can do multiple intermediate operations on a sequence, but at the very end, you'll need a terminal operation to actually pull your results out from that sequence. And lastly, I just want to reiterate this again. Sequences as advertised might appear to be super performant, but this is not always the case. You can just use simple iterables for the most simple use cases, and the benefit is only when you have huge lists and you have multiple chained operations. Well, that's it for the show, folks. I hope you enjoyed the show. Make sure to look at the show notes this time because you'll find some really useful code snippets and resources to some of the stuff that I used to research this. Thank you all for listening, and we will catch you in the next episode. Once again, we want to thank Mapbox for sponsoring today's show. Mapbox handles all your map and location needs, so you can focus on just building your app. With their simple APIs, they provide the easiest way to build a customizable map experience in your Android app. Driving, walking, biking directions, location search, geocoding, reverse geocoding, they got it all. Head on over to mapbox.com/Android to get started. Thank you so much for sponsoring today's show, Mapbox. That's it for the show, folks. Fragmented is hosted by DonnFelker and me, Kaushik Gopal. We edit and produce all the episodes here on Fragmented. Sarah the Amazing Jackson from the Spec Network helps with production assistance and wraps our final mix. Our theme and ad music is by the national recording artist Blueprint from Weightless Recordings. You can find more Fragmented episodes at fragmentedpodcast.com. Thanks for listening, and we will catch you in the next episode.